Okay, so today we are going to start the new chapter, right? We are on the topic of paper one. In the last lesson, we have done data representation, chapter 3. Okay, so can you tell me which topic you are doing in your class, school?
Right now we're just doing revision for our mock exams, but before that we were doing, I think it was Unit 7.
Unit 7. Okay, database,
One sec, let me check.
please check.
Oh yeah, it
Great,
was databases
perfect.
and
So now
SQL.
we are going to start SQL. So SQL, structured query language. The full form of SQL is structured query language, right?
Mm-hmm.
Before starting SQL, let's discuss about the database. What do you mean by database? So a database is a persistent store of organized data. It means that database is a kind of data organization. Maybe you're going to store your data in a form of a table like this. So it means you're organizing your data in a form of rows and columns. So this is also called database. Basically, database is a collection of data in an organized form. So you may easily retrieve your data anytime, anywhere, whenever you want. So persistent means that the data in the database will remain there until it is specifically deleted. Like you are in grade 11. Before that, you were in grade 10. So definitely your teacher deletes your name, your data from grade 10, because now you have passed to the grade 11. So while we are going to complete one session, our data will no longer be needed. So we can delete it, right? So this thing is called persistent. Persistent. Is that okay?
Mm-hmm, yeah.
Okay. So organization means that the database is a structured look into records, fields, and tables. Like here, you're taking a serial number, you're taking name, and you're taking class. So how many fields are there? 3 fields are there. First field is a serial number, second field is a name, and third field is a class. So this is called columns or fields. What it called? Columns or fields. And then you have a rows. Like in your row, you're going to write down serial number 1, name A, class 10th. Serial number 2, name B, class 10. Look, so this is the thing I'm feeding it. So this is called records or record, whatever you pronounce it. It is a record, or you can say record or raw. In a simple word, you say, sir, it is a raw. So look, you have write on a record in a raw, you have a columns. This things makes your data more presentable. This organization of data makes or creates database.
Mm-hmm.
Any confusion?
No.
So there is a data in the database. Look, the data is like serial number A, name, serial number 1, name A, class 10. This is a data. So a record is a data structure. So this 1, 2, 3, 4 are called records. Like these are the records about the names C and D. So this is a particular record about name A, then name B, then name C, and then D. So a record is a data structure that allows multiple data items to be stored in different fields. What is the first field? Serial number. Then name. then class. It means we have multiple data items into the multiple fields. So we are going to recognize every field by its name. So the first field is serial number. The second field is name. The third field is class. So it means that we are going to put the name in order to identify each item of data. So let me ask you, can you tell me number 2 class? You can say, sir, number 2 class is 10th. Number 2 name is B. So look, you are identifying everything easily. In this way, the data becomes easier to understand, easier to read. To create a record, we must first define the field names. So I have already done it for you, like serial number, name, class. So that will make up each record, and then you're able to understand what basically goes inside the table. So they have given you the fields: student ID, that's called serial number; first name, that's called name, yes, and surname, father name. So if you are going to organize this data or define this data, you can create a table like this. So in this table, what is the name of this table? What is the name of this table?
Student.
Student. How many fields are there?
3.
How many rows are there?
4.
Perfectly fine. So you can see students showing how many records? 4 records. Number 1 is Bradley. Number 2 is Jamie. Number 3 is Charlotte. And number 4 is Imogen. Is that okay?
Yeah.
So this is a table, right? The above table has 3 fields and 4 records. The student ID field, however, has the special purpose. It is field that uniquely identifies a record. Now the question is how the computer is going to read our data. So we have 3 fields: student ID, first name, and surname. Among these 3 fields, you have to apply what? Apply a key field that is called primary key. Primary key is the most important and most versatile key in our database, which identifies the data, which helps computer to read the data, which helps computer to start reading the data. So we declare primary key. So the question arises, why primary key is needed? So I told you primary key is needed in order to make your data readable by computer. So the computer is able to understand that from here or from here or from here, computer start reading the data. Now, which field among 3 is able to be a primary key? What do you think? Student ID, first name, or surname? Which field do you think deserve to be a primary key? Yes, this is the question. Sir, how could I recognize it? That which key is being a primary key? Let me tell you. Primary key is always unique. It means no data will be repeated in any other record. So the data must be unique. So what do you think? Which field have the unique data? Like you can say first name. In first name, maybe in your class, there are 2 persons whose name is Jamie. So this is not unique. The thing is repeating. Surname, maybe 2 people have the same surname. So it is also repeating. So which data is not repeating?
Student ID.
Student ID. So this is a unique data because it's not going to repeat again and again. Remember, if in your school there are 5,000 students, what do you think? 5,000 students, any of 2 or 3 students have same name? Yes, it is possible. Like many girls' name is Mariam. Like maybe in your school there are 4 Mariam, right? Maybe their surname is also same. This is also possible that many students have named Mariam Kashif. This is possible. But what is the thing which makes you unique in your school? Your ID. Your ID is always unique. So if you're going to be called and your receptionist asks, who's Mariam Kashif? Like, we have three Mariam. So you can tell that the student ID 027341. So they can easily recognize you. So the student ID is a unique key. Now, did you get an idea about unique?
Yeah.
It means not repeating. So name is able to repeat, surname is able to repeat, even contact number is also possible to repeat. Maybe in your class there are two brother and sisters, so their contact number is also same. What do you think?
Yeah.
So you cannot make contact number as a primary key. You can say, sir, contact number is also able to be a primary key. Yes, it is. But maybe if there are four kids of a same person in a one school, so four kids have the same contact number, right? So student ID has another student. The field that uniquely identifies a record is as the primary key. And every table should have one primary key, right?
Yeah.
Great. So what you have to do, you need to write down the definition of database. I'm writing just DB. You have to write down the definition for primary key. I'm writing PK. And you need to draw this table with rows and columns, right?
Okay.
Okay, do it now. So far, this table is well organized. However, if we extend the table to also store about the registration class that each student is in, we quickly run into the problems. Like, now we are going to just extending the data in the student, so it becomes student registration. The name is changed now. And you can see we have three fields up there: student ID, first name, and surname. Now we are going to add three more: registration class, teacher name, and the room number. So note now that the table stores data about both student and registration classes. We ran into a problem of data redundancy and data inconsistency. So you can see we have first name, then surname, then registration class 9A, then the teacher name, Fredo, and the room number, and so on. Now we are going to face two problems here. The problems is known as data redundancy and data inconsistency. First, data redundancy is where data is repeated in a database table. For example, we know that group 9A is taught by Mr. Cadrock and 10B is taught by Mr. Thompson, but this is shown more than once. You can see here, then Mr. Thompson, right? If we extend the number of records in the table to include data about all of the students, the same information would be stored once per student in each class. Of course, because if you are reading in 9A and if there are 70 students reading in 9A, so the same teacher name will repeatedly there. What do you think?
Yeah.
Okay, so let's see. This makes the database file much larger than it needs to be. So data redundancy means the repetition of same data in your database that makes your database more lengthy, right? This is called data redundancy, right? Now, see, data inconsistency leads on from data redundancy. If data is stored multiple times, what if it isn't always the same? An example of this is shown in the table above. Is Mr. Craddock's class in room 7 or room 8? Look, this is a confusion here. The teacher is same. The class registration is same, but the rooms are different. This is a big thing we need to confirm. What's going on here? Right? So the more
Yeah.
repeated data there more likelihood there is that errors are introduced and that some of the data will be inconsistent. So this is called inconsistency, that data is not reliable. You are confused that which room Mr. Caddox lie on, like he's in grade room number 7 or room number 8. So these are issues which rises in database if we are repeating the same item of data all time. Is that okay? Now, our next topic is relational database. What do you mean by relational database? If you are working on 2 or more tables, it means that 2 or more tables should be connected with each other. And this thing is called relational database. It is made up of more than one table. This removes the problems of data redundancy and data inconsistency. So now the things are, kind of bit solved here, that if we have 2 or more tables in one database, let me show you how. Like you see, this is your student table, right? How many fields are there?
4.
4 fields are there. Okay. So using the previous example, we can split the student registration into 2 separate tables. One to store data about a student and one to store data about registration class. Now we are going to split. See this. The registration table having 3 fields: registration class, teacher, and the room code. And the previous one related to the student ID, name, surname, and registration class. Did you notice one thing in both tables? Any column which is common in both, look this one and look this one. Again, observe this one, student ID, first name, surname, and registration class. And now look this one, registration class, teacher, room code. Is there any field which is common, like which presents in both tables?
The registration class.
Yes, this makes sense. It means that in both tables, there is a column which is common. So let's see what happened. Each table stores data about a different type of object, person, thing, or idea. In this example, the first table stores information about the students, and second table stores information about registration class. We are clear, right? The primary key of the registration table is registration class field. This one is the primary key. So I'm writing PK, primary key. Is it okay?
Yeah.
Okay. Okay. No two registration class have the same value for this field. Okay, so everything is unique here. You can see. So it's unique. It means we can pick it. Okay, to link the tables together, the primary key from the registration table is included in the student. Yes, we know this already. That registration class is present in both tables, isn't it? It is present in both tables, right? So it means that this table, this particular key should be linked. How? Let's see. Such a field is known as a foreign key of the student table. Okay, in the registration table, registration class is a primary key. And this same key, look, in student table, considered as foreign key. Considered as foreign key. Are you getting it?
Yeah.
I'm just writing F4, foreign key. So registration class in student table is foreign key, and the registration class in the registration table is a primary key. Two types of keys are there, foreign key and primary key. Primary key works in the same table, but the same primary key is present in any other table is referred as foreign key. So this primary key is going to connect both tables as this is common in both tables. So this make a relation between two tables. Let me explain you in some different way. Just give me a second. I'm explaining this in some different method. Okay, there we go. Okay, database, SQL database. This is our chapter name. AQA computer science. And the topic is relational database, right? Okay, what I have to do, I need to draw the table. Okay, this is my table. What are the fields name? Let me see. Student ID, first name, surname, registration number. Student ID, first name, surname. I need to add the column here. Registration class, right? This is our column. This is our student table, right? Okay, now I need to draw another table for you. Registration class, teacher, and room. So registration class, then teacher, and then room. Right? Is that same? Okay. Now, what is the topic? Relational database. It means that you see this registration class is present in student table, and the same is present in registration table. These are our two tables, right? So you can see the same column is used in both tables. In this way, it is going to create a relation between these two tables. Now I think I'm clear. So look, the registration class is the column which is unique, not unique, sorry, and which is present in both tables. So it is going to make a connectivity between both tables. And this thing is called relational database. So right here in the registration, this registration class is a primary key, right? It is a primary key. But in the above table, it is considered as foreign key. I think now it's clear in your mind.
Yeah.
Right? So this is how the relation developed between two tables. It must have one column, which is common between both tables. Right? That's great. That's great. Okay. I'm moving on my topic again. Okay, right. So relation database may be more than 2 tables. Some complex database system may have over 100 tables. 100 tables. What do you think? Is it easy to understand? It's very, 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 very complex, right?
Mm-hmm.
So with this in mind, we could expand our students database table with another table, this time to tell us more about the rooms that are used by each registration group. So a room table could use the name of the room as a primary key and tell us we need to know about each room. So you can see we have another table now that's called room table. In room table, room code is there, location is there, and the facilities is there. So now the primary key of the room code is the foreign key of the registration table. So look, room code is present here, this column. And the same column is present here. Look. Okay, one thing I'm doing it. I'm doing it for you. Just a second. Room table. Okay, I'm moving back to explain you. Okay, this time our table name is room table, right?
Mm-hmm.
Okay, just a second. I'm drawing it. Okay, so the columns are, okay, the columns are, first the room code is there, then location and ID facilities. Perfect. Location, oh, location, IT facility. Okay, now, can you tell me, in the above registration, you can see there is a room code column right here. Look. And now we have room code right here. So this time room code is a primary key here. And the same room code is, come on, foreign key here. In this way, both are related with each other. Look, they are now related with each other in this way. Look. So the relation is developed. So how many tables we have now?
3.
Perfectly fine. So what you have to do, you need to write down your notebook. You have to make a relation table topic and make these 3 tables, draw the relation between them and write a paragraph in your own wording and send me the picture.
Okay.